Hello and good morning friends, welcome to CEC live lecture. Dear friends, today in this session we are going to talk on one of the important tests, and the test is Z test. We are going to talk on Z test data analysis. Dear friends, as you might be knowing that Z test is usually done when the sample size is large. Now you might be curious why we are talking on today's topic, that is on Z test. Dear friends, for all the students who are into research or who want to research something new, for them this test would be very beneficial, and we would be talking on the applicability of Z test, how it is useful. And for this discussion we have once again with us in our studios Dr. Namita Rajput. Dr. Namita Rajput is principal in Sri Aurobindo Evening College, University of Delhi. Dr. Rajput is a prolific professor who believes in giving her utmost knowledge to the students. She has authored numerous books and number of her articles have been published in reputed journals. Friends, if you want to ask questions from Dr. Rajput on today's topic, then do call us through our toll-free number. Our number is 1-800-110-430. I repeat, our number is 1-800-110-430. So let's welcome our guest, Dr. Namita Rajput, and let's try to have deep insight into today's topic. Hello ma'am, welcome to the lecture.
Good morning friends. Today we will be talking on a very important test called Z test. It's a statistical method for the large samples. Now, as you all know, the use of any kind of a statistical method for analyzing of the data is based on the objectives of the study, the hypothesis to be tested, and the type of available statistics data which is to be analyzed to answer the research questions. So it is a very important thing which you have to analyze here, that any type of test cannot be put to any type of a research question. There is a difference in the permutation combinations which you are taking. There is a difference in the objectives of the study which you are undergoing, and definitely there is a difference in the type of the objectives of your study. So depending upon so many questions here, the type of the test which you are going to use for the analysis of the data or the statistical data differs from one study to another study. And for any type of a differential study, we have a different type of test. Like if you are moving for a test which is having a sample size less than 30, then student t test is used. And of course if the sample size goes on increasing from greater than 30, then we are going to use the Z test. So we are going to talk about the Z test in detail, and at what circumstances it is used, what are its assumptions, what are its suitability, so that you have a great insight of how the test is being used and its usefulness in relation to the research questions of the of the student who's undergoing any kind of a research study. So there are different types of statistical tests. How to tell if something or some things is different from something else. So it's like if you're comparing the data, like sample A is different from sample B, or B is different from sample C. So this kind of a orientation, we have basically two types of data in front of us. The primary or secondary is the first category. The qualitative or the quantitative is the second category. Now, I will tell you the differentiation between the primary data and the secondary data, and of course the qualitative data and the quantitative data, because unless and until you are very clear about these terms, you will not be able to apply the type of the test in detail, and the suitability also will not be very clear in the minds of the researcher. So we'll start with what is the primary data. As the name suggests, primary data is the data which is collected by the researcher himself. The orientation is very focused, very clear. So he frames the objectives, he frames the questions accordingly, because this is his own work. He's not depending on anybody else. He's depending upon his own mind, his own questions and his own orientation in this regard. So he's very clear and focused and very clear in his mind that what he is going to collect, and this is what is called as the primary data. So to be on the professional side, let us have a clear-cut definition of the primary data here. The primary data is that which is collected by the researcher to address the current research. Now coming on to the secondary data. The secondary data refers to the data gathered by the others or from other studies like official records, publications, documentations, etc. So I'll be talking on these two once again. The primary data is the data, as I have told you in detail, is done by the researcher himself, and on the contrary, the secondary data is collected by the somebody else and used by somebody else. So the data which has been collected by somebody else is having a different orientation, different objectives, a different set of frames, different assumptions. So like we have exchequer of the country, like the government, which collects the data for its own policy making, policy formulation, policy revision, framing of strategies, program, welfare schemes, etc. So they collect the data with that kind of an orientation. But here, the secondary data, you must have a clear orientation in mind that it is done with the different orientation, with the different objectives, and is collected and gathered by somebody else and used by somebody else. So there are a lot of publications in this regard, a lot of journals are there, a lot of reports are there. So the data will be uploaded on the websites, and according to what the researcher has framed the questions in his mind, he will match the objectives, he will match the data, and if the data and the orientation and the objectives are matched, he will download and use the data. So this is what is called as a secondary data. So I think the distinction between the primary data and the secondary data is very clear in terms of the orientation and in terms of the gathering and the using aspects of it. Now we have another categorization which is called as quantitative and the qualitative data. As the name suggests, the qualitative data refers to the data having the counting of the individuals for the same characteristics and are not measurement. The quantitative data refers to the data having magnitude, characteristics, and is measured either by an interval or on a ratio scale. So here the main difference between the qualitative and the quantitative data is in terms of the measurement. The qualitative data is not measurable, is not clearly measurable in terms of like the quantitative data is, which can be measured in intervals or in a ratio scale. Whereas the orientation, as far as the qualitative data is concerned, we have to transform and convert that data into some scale, and then only we can measure that. So you have to adopt certain steps to convert the qualitative data into the quantitative data or to convert it into some kind of a measurable scale. So this is how we have the four categorization. I hope these things are very clear to you. The first was the primary data, as the name suggests, is collected by the researcher himself, followed by the secondary data in which the orientation is different. It is gathered and collected by somebody else and used by somebody else. The third was qualitative data, in which the data is not measurable clearly, but we transform the data into certain scales and only then we can measure it. Then we have a quantitative data, which is, as the name suggests, it is measurable very, very clearly, either on an interval scale or on a ratio scale. So taking it forward, let us start with the hypothesis testing. This is the most important step for any basic researcher who has just started with the orientation of how to start the research work. Now, sometimes we cannot survey or test all the objectives and the persons of the population. So here we have to take a sample, because to study the population, to study the universe is a very difficult task, because it is too time consuming. It has got a lot of energy used, it is having a lot of resources to be used. So here the simple thing is to select a correct kind of a sample. The sample is a representative of the whole population. You will study that sample, you will start drawing inferences or examples or conclusions out of it, and then you're going to apply those into some kind of a usage of that kind of a conclusion of the data collected. So here we are starting of selecting a sample. So from the results of the analysis, from a sample data, we can predict the results from the population. Some questions that one may want to answer are, these are just examples, are unmarried workers more likely to be absent from work than the married workers? Are the 6th graders in a certain school significantly less skilled in their mathematical abilities than the average student in the district? Third, in the fall 1996, did the students in maths 16301 score the same on the exam as the students in Maths 164 2? Is there any difference between the strengths of the steel wire produced by XY and the Bob's Wire Company? Fifth, a hospital spokesman claims that an average daily room charge for a specific procedure is rupees 2000. Now, these are the statements which we are trying to prove, and the orientation is whether these statements are correct or not. So, these are the assumptions which we start and calling as the hypothesis. So, these things we have to prove that what we are claiming, what we are assuming is correct or not. So, how do we do that? We start with a hypothesis. Now, what is a hypothesis? Every researcher must know how to frame a hypothesis, because if this step is wrong, the subsequent steps which you will take will also be wrong. So, starting with the orientation of the meaning of the hypothesis. The hypothesis is generally considered the most important instrument in the research. Its main function is to suggest new functions and ideas. In the social sciences, where direct knowledge of population parameters is a rare, hypothesis testing is the often used for deciding whether sample data supports our purpose or not. So, we have seen the definition aspect of a hypothesis. Here, we must understand that it is a kind of an instrument which we start observing the assumptions of what we are having the orientation in mind, and definitely we are talking about certain parameters of the population, and it is about the testing of that kind of a statement, whether it is right or wrong. Generally, hypothesis is considered as an assumption or a supposition which has to be proved or disproved. So, we have two things in mind: whether the assumptions which is there in the mind of a researcher, whether he can prove it or it is disproved. So, it's not that easy to say any kind of a statement that yes, this is approved and this is not proved. We have to follow a certain steps. We have to be very clear about the statements. We have to be very justifiable in our and rational and judgmental in our approach, so that there is objectivity which is maintained in the research work. We cannot apply our whims and fancies into it, and unless and until we are very clear about how to frame, how to use, how to proceed, how to conclude, how to draw inferences, then every step which you take is wrong. So, the formal researcher who is starting with the research work must be very clear in his mind how to frame the hypothesis, how to move on the path of proving it or disproving it. So, we have two routes to it. Either we prove that hypothesis to be correct, or we disapprove that hypothesis to be incorrect. So, the researcher hypothesis is a formal question that he has to solve himself, but yes, his parameters should be very clear, his assumptions should be very clear, whatever statements he is making should also be very clear. There should not be any room for subjectivity in whatever he is doing. He has to be objective in his approach, because whatever we do in research is followed by some evidence, and we call it as the empirical work. So, to have the faith in the research work, this kind of a standards must be maintained by the researcher. So, taking it forward, the hypothesis may be defined as a proposition or set of propositions set forth an explanation for the occurrences of some specific groups of phenomena. A research hypothesis is a predictive statement capable of being tested by scientific methods that we relate an independent variable to some dependent variable. We will give you some examples here to have a clear understanding of what hypothesis is. The example: the mileage of an automobile A is as good as automobile B. The royal and the loyalty of the customer of brand A is better than brand B. These hypotheses are capable of objectively verified and tested. Now, these are the examples to make a very clear understanding of what hypothesis is. We are starting with this kind of an assumption that yes, we have two products A and B, and as far as the loyalty is concerned, the customers are more loyal to product A or brand A than brand B. So, this is a statement which can be empirically proved by collecting the data, In terms of the structured questionnaire, you would be asking the questionnaire from the customers, asking about their loyalties, that whether any option is given to you, whether you would like to stick to product A or B. So if the answers are collected in a very systematic manner, in a structured format, in a questionnaire, it is very easy to verify the claims that yes, product A customers are more loyal than the customers of product B. So, these kind of statements can be verified very easily. Now coming on to the characteristics of a hypothesis, that what are the basic nature, what are the characteristics, what are the basics of a hypothesis. So let us have a look on this. The hypothesis should be very clear and should be precise. Hypothesis should be capable of being tested, and the hypothesis should be able to relate to a variable. Now as we move on with the research, we have certain variables in front of us. Variable A, variable B, variable C, etc. So whatever we have to test, whatever is there in the mind of the customers, we must have a very clear understanding, and the hypothesis which we are framing should be very clear and precise. Followed by, it should be capable of being tested. If it is not being capable of being tested, then that means there is a problem in the formation and the formulation of the hypothesis. Third, it should be able to relate to a variable, like we are talking about the customers, we are talking about the products, we are talking about the loyalty aspects. So these things are measurable and they also relate to variable, because whatever we test, we have to test through a variable. So you must relate your research questions to the variables under study. The hypothesis must be limited in scope and must be specific. The hypothesis must be stated in a very simple terms. The hypothesis must be consistent with most known facts. So as you understand, we have to limit, we have to be very clear about the orientation aspects of hypothesis. Unless and until we are very clear about the hypothesis or the formulation or the different aspects of the hypothesis, we will not be able to move forward. So one thing should be very clear in mind, that the hypothesis which you frame are simple, measurable, limited in scope, limited because unless and until you bound them in some boundaries, how will you test it? The more specific and the clear hypothesis is, the better it is. Then of course, we must have certain consistent and certain known facts about the hypothesis which you are going to test. The hypothesis must be testable within a reasonable time, because the time factor is most important. If you are trying to test the market today and you're getting the statistics day after tomorrow, what is the use of it? So you have to be very specific about the timings, and you have to limit the test aspects in a time frame. Then of course the hypothesis must explain the facts which most needed explaining. Now coming on to the basic concepts concerning the testing of hypothesis. Null hypothesis and alternative hypothesis. In statistical analysis, if we want to compare method A and method B, if we proceed with some assumptions that both methods are equally good, then this assumption is termed as a null hypothesis. When we are starting with the basic concepts concerning the testing of hypothesis, there are two things. One is a null and the second is the alternative. The first is the null and the other is the alternative hypothesis. In the statistical analysis, if we want to compare the method A with the method B, and if we proceed with the assumption that both methods are equally good, then this assumption is termed as a null hypothesis. The basic concepts concerning the testing of hypothesis. As against this, we may feel that method A is better than method B, and then we call it as an alternative hypothesis. In a null hypothesis, we try and negate, but in terms of the alternative hypothesis, we are having a different orientation in terms of what is null and what is alternative hypothesis. Now, the null hypothesis is generally termed as H0 and alternative hypothesis symbolized as HA. coming on to the basic concepts concerning the testing of hypothesis. Suppose we want to test the hypothesis that the population mean mu is equivalent to hypothesized mean, that is mu 0 is equal to 100. The null hypothesis would be the population mean is equal to hypothesized mean, that is h0 mu is equal to mu h0 is equal to 100. So this is the one thing should be clear in the minds of the researchers, that you have to frame a null hypothesis in which you are trying to negate the relationship between the variables. And we are taking this as h0 is equal to h1 in terms of h0, that is the mu is equal to mu h0 is equal to 100. The null hypothesis, that is h0, represents a theory that has been put forward either because it is believed to be true or because it is to be used as a basic of the arguments, but has not been proved. For example, in a clinical trial of a new drug, the null hypothesis might be that a new drug is no better or an average than the current drug. We will also write H0 is equal to there is no significant difference between the two drugs on an average. So here we are trying to test the clinical trial of the two drugs. In the null hypothesis, we say that this new drug is not better than an average drug which was earlier initiated. So here we are trying to say no, and there is no significant difference between the two drugs on an average. Now the basic concepts concerning the testing of hypothesis. This is so important that unless and until you have a basic understanding of what is H0, what is H1, what is the formula, what are the assumptions, what are the terms used, you will not be able to use it in your research work. So in our sample, results do not support this, that we assume something else is true. The alternative that we will accept is known as alternative hypothesis, that is HA. Alternative hypothesis would be H0 mu is not equal to mu H0, that is the population mean is not equal to the hypothesized mean. Now coming on to the basic concepts concerning the testing of hypothesis. The alternative hypothesis, that is HA, is a statement of what a statistical hypothesis test is said to be established. For example, in a clinical trial of a new drug, the alternative hypothesis might be that the new drug has a different effect on an average compared to that of the current drug. We would say and write HA, the two drugs have a different effects on an average. The alternative hypothesis might also be that the new drug is better on an average than the current drug. So in this case, we would write HA, the new drug is better than the current drug on an average. Now coming on to the basic concepts concerning the testing of hypothesis. H0, that is mu, is less than mu H0. The population mean is greater than the hypothesized mean. H0 mu is less than mu H0, that is, population mean is less than hypothesized mean. The null hypothesis and the alternative hypothesis is chosen before the sample is drawn. Unless and until we fix the null and the alternative hypothesis, we cannot have a good sample drawn from the population which we are trying to test. Now we are talking about certain considerations which have to be kept in view while framing the hypothesis H0 and H1. So the alternative hypothesis is one wants to prove, followed by the certain considerations which have to be kept in mind while framing the alternative and the null hypothesis. So we give special consideration to the null hypothesis. This is due to the fact that the null hypothesis relates to the statement being tested, whereas the alternative hypothesis relates to the statement to be accepted if when the null is rejected. Now we have another statement in front of us. The final conclusion, once the test has been carried out, is always given in terms of a null hypothesis. We either reject H0 in favor of alternative hypothesis, that is HA, or do not reject H0. So we never conclude, reject HA, or even accept HA. Now if we conclude do not reject H0, this does not necessarily mean that null hypothesis is true. It only suggests that there is not sufficient evidence against H0 in favor of HA. Rejecting the null hypothesis then suggests that alternative hypothesis may be true. So, there are certain errors which we commit, type 1 error and type 2 error, in terms of accepting or rejecting the null hypothesis. So, you have to be very careful in this regard. So, we start with type 1 error. In a hypothesis test, type 1 error occurs when the null hypothesis is rejected. When it is in fact true, this is H0 is wrongly rejected. We are following this with an example, that is the type 1 error or error. For example, in a clinical trial of a new drug, the null hypothesis might be that the new drug is no better or alternative than the current drug. So this is H0. There is no difference between the two drugs on an average. A type 1 error would occur if we concluded that the two drugs produce different effects, when in fact there was no difference between them. The type 1 error followed by the table gives us a summary of the possible results of any hypothesis testing. So please give attention on this regard. On the left hand side we have a truth. In the middle side we have two, the null and the alternative hypothesis, and in the last column we have the decisions. There are two types of decisions which have to be kept in mind. We have to reject the null and do not reject the null. There can be two assumptions and two results. Either we accept or we reject. If we reject, we do not reject. So H0, that is the null hypothesis, when rejected, it is type 1 error, and H0, we do not reject the null hypothesis, is a right decision. Alternative hypothesis, that is HA, is a right decision if it is the H0 is rejected, and if HA, we do not reject the H0, this is a type 2 error. So please have a clear orientation of what is type 1, what is type 2, how it is being formed, why it is rejected, why it is accepted. Now type 1 error is often considered to be very serious compared to type 2 error, and therefore more importance to avoid than a type 2 error. The hypothesis test produces a therefore adjusted so that there is a guaranteed low probability of rejecting the null hypothesis wrongly. So if you compare the two types of error which you commit, that is type 1 and type 2, type 1 error, if committed, is a more serious thing than type 2 error. So you have to be very careful about do not commit any type of error, whether it is type 1 or type 2. But if you have a comparison between the two, type 1 error is more serious than compared to type error 2. The type error 1 is often considered to be more serious, as I said, and definitely should be avoided in all circumstances. But yes, a good researcher should avoid both types, type 1 and type 2 errors. Type 1 error, this probability is never 0. This probability of type 1 error can be precisely computed as P type 1 error is equal to the significance level. The exact probability of type 2 error is generally unknown. If we do not reject the null hypothesis, it may still be false, a type 2 error, as the sample may not be big enough to identify the falseness of a null hypothesis, especially if the truth is very close to hypothesis. Next, we have type 1 error. For any given set of data, type 1 and type 2 errors are inversely related. The smaller the risk of one, the higher the risk of the other. A type 1 error can also be referred to as an error of the first kind. Now we have the second type of error in front of the screen. We call it as a type 2 error. In a hypothesis test, a type 2 error occurs when null hypothesis is not rejected, when it is in fact false. So this is also very serious, but type 1 error is more serious compared to type 2 error. We give you an example here. In a clinical trial of a new drug, the null hypothesis might be that the new drug is no better on an average than the current drug. This is H0. There is no difference between the two drugs on an average. A type 2 error would occur if it was concluded that the two drugs produced the same effect, that is, there is no difference between the two drugs on an average, when in fact they produce the different ones. Type 2 error is frequently due to a sample size being too small. The probability of type 2 error is symbolized by and written as P type 2 error is equal to but is generally unknown. A type 2 error can also be referred to as an error of the second type. Now coming on to a significance level. The significance level of a statistical hypothesis test is fixed probability of a wrongly rejecting the null hypothesis at 0. It is in fact true. If it is the probability of a type 1 error and is set by the investigator in relation to consequences of such an error, that is, we want to make a significant level as small as possible in order to protect the null hypothesis and to prevent as far as possible the investigator from inadvertently making the false claims. The significance level is usually denoted by a significance level is equal to P type 1 error. Usually the significance level which is chosen is at 0.05, that is 5%. Now coming on to one-sided test. A one-sided test is a statistical hypothesis test in which the values for which can reject the null hypothesis H0 are located entirely in one tail of the probability distribution. Next we have a significance level. In other words, the critical area for one-sided test is the set of values less than the critical value of the test, or the set of values greater than the critical value of the test. A one-sided test is also referred to as a one-tail test of significance. The choice between one-sided and two-sided test is determined by the purpose of investigation or prior reason for using a one-sided test. Coming on to the significant level. Suppose we want to test a manufacturer's claim. There are on an average 50 matches in a box. We could set up the following hypothesis: H0 mu 50 as against HA mu less than 50 or HA mu greater than 50. Either of these two alternative hypotheses would lead us to one-sided test. Presumably, we want to test the null hypothesis against the first alternative hypothesis, since it would be useful to know if there is likely to be less than 50 matches on an average in a box. No one could complain if the correct number of the matches in a box or more. Now coming on to a significance level. Another alternative hypothesis could be tested against the null, leading this time to a two-sided test. H0 mu is equal to 50 as against HA mu is not equal to 50. Nothing specific can be said about the average number of matches in a box, only that if we could reject the null in our test, and we would know that the average number of matches in a box is likely to be less than or greater than 50. Now we have two-sided test. in two-sided test, the rejection area is on the both tails. A two-sided test is a statistical hypothesis in which the values for which we can reject the null hypothesis are located on both the tails of the probability distribution. In other words, the critical reason for a two-sided test is a set of values less than the first critical value of the test and the set of values greater than a second critical value of the test. A two-sided test is also referred to as a two-tailed test of significance. The two-sided test. The choice between one-sided test and the two-sided test is determined for the purpose of investigation or prior reasons for using a one-sided test. Now, coming on to a very simple definition of a hypothesis. Now, as we have come to the overall conceptual framework, hypothesis is a statement for the value of a population parameter developed for the purpose of testing. For example, the hypothesis or the statements made about the population parameters are the mean monthly income from all sources of systems analytics, 20% of all juvenile offenders ultimately are caught and sentenced to prison. So, it is a procedure which is based on the evidence and the probability theory used to determine whether the hypothesis is a reasonable statement and should not be rejected or unreasonable should be rejected. Now, we discuss the 5 points to frame the hypothesis testing. So, we will do it one by one so that you have a clear understanding of how to frame the hypothesis. The first is state the null hypothesis and the alternative hypothesis. The null hypothesis is about the statement about the population parameter. The alternative hypothesis is accepted if rejected proves null hypothesis to be false. The second step, select the appropriate test and the level of significance when testing a hypothesis of the proportion. We use the Z test, and the Z test is equal to P cap minus P under root of PQ upon N. When testing a hypothesis of a mean, we use the Z statistics or we use the T statistics according to the following conditions. If the population standard deviation is known to be either data is normally distributed, the sample size n is greater than 30, we use a normal distribution, that is the Z statistics. When the population standard deviation is unknown and either the data is not normally distributed, we use T distribution. The traditional guidelines for choosing the level of significance is as follows: 0.10 level of political polling, 0.05% level of consumer research projects, and 0.01 level of qualitative assurance work. Now, coming on to the decisions. The decision rules that the conditions under which the null hypothesis will be accepted or rejected. The critical value for the test statistics is determined by the level of significance which you choose. Either it is 10%, 1% or 5%. The critical value of the test statistics is determined by the level of significance. As we have discussed, there are 3 levels. The critical value is the value that divides the non-reject regions about the overall conceptual framework in terms of what is there and what is not there. So, we have today studied about what is a null hypothesis, what is an alternative hypothesis, and how we are going to take up whether the sample size is small or sample size is bad. So, if the sample size is greater than 30, we take into consideration the Z test. If it happens to be less than 30, we call it as the T distribution test of the hypothesis. Whatever values, parameters, characteristics of the population which we are taking into consideration are very clear, then we frame the hypothesis. The hypothesis is of 2 types, the null hypothesis and the alternative hypothesis. The null hypothesis negates the relationships between the variables to be studied, and the alternative hypothesis is about in the contrary to what we have tested in the null hypothesis. So, we denote the null hypothesis as H0 and we denote the alternative hypothesis as H1. We have talked about the various parameters into it, that it has to be a normal distribution, about the sample size to be taken, and it is entirely to study the entire population by a researcher is a tough job. So, when you are having a closer and a deeper study, we have to have a sample out of that population. Great care has to be taken while selection of the sample from the population. that should be a true representative of the population in study, followed by that the number into consideration, whether it is 30 or greater than 30. If it is less than 30, we use the T distribution test, and if it is greater than 30, we call it as a Z test. So these parameters, these assumptions about the population, then about the accept reject rule, then about the errors to be committed, that is the type 1 and the type 2 errors, you have to be very categorical, you have to be very careful while doing each and every step. If one step is taken wrong, the subsequent steps will have a negative spillover onto your inferences, and whatever you have done in terms of your research formulations, hypothesis formulation will be multiplied by 0. The type 1 error which you commit is more serious than the type 2 error. So in fact, you should not be committing any type of error, whether it is type 1 or type 2. But when it comes on to the which one is a lesser evil, we call it as a type 1 error, should be avoided at any cost. So the meaning, the conceptual framework, the assumptions, the types, the steps, and the care, the types of errors to be committed were the part of today's lecture, and I hope you have followed it. And next time we will be having a hands-on training on how to practically do a Z test and draw each and every step out of it, because today was a theoretical backdrop, which is also very important to understand and to implement the conceptual framework. But yes, for sure in the next lecture I would be talking on the hands-on aspects of how to handle the data, how to actually implement the data, and how to draw the inferences, the test statistics, and finally that whether the null hypothesis is accepted or it is rejected. Thank you so much.
With this note, thank you, ma'am. Thank you so very much for giving us a productive and elaborative session on Z-test data analysis. When we compare Z-test and T-test or the other test, how these tests are differ from each other?
Actually, the inferences and the other parameters are the same. But yes, in terms of Z-test, the sample size is greater than 30. And if it is less than 30, we use the student T-test distribution test. It's about the sample size that we differentiate between these two types of tests.
So what are the other applicabilities of a Z-test other than the sample size?
See, whenever we are starting with the research work, there are certain assumptions of the populations which are, tested. So how to test the hypothesis is very important. And for this orientation, we have certain types of tests which is definitely important for the application of which test to be used.
Definitely, dear friends, we believe that you might have gathered maximum information, maximum knowledge through this live session where we discussed on Z-test, and as Dr. Namita Rajput herself said, that we would be discussing in detail in our future sessions and would be gathering more information through her. Friends, if you want to have a look on this session once again, then we would like to tell you all that we are going to upload this lecture on YouTube very soon. So you could watch the lecture, and afterwards, if you feel so that you have certain questions to be answered, then do write to us at info.cec@nic.in. This is the ID through which you can contact with us, and definitely we'll try to give answers to your questions when next time Dr. Namita Rajput visits our studio. Dear friends, if you want to see more lectures on this particular topic, on this particular series, then you need to log on our YouTube channel. Our YouTube channel is www.youtube.com/CEC-EDUSAT. There you can watch the entire series, all the lectures pertaining to the series, as well as you can see all the lectures pertaining to the other series and other subjects also. So friends, we would be meeting again very soon and would be discussing further. Till then, take care. Goodbye. Thank you, ma'am. Thank you so very much.